Then this question is given that a Carnot engine with a perfect gas acting as a working substance is operated backward and it is employed to freeze water at 0 degree Celsius. So here you can just consider that this heat engine is behaving like a refrigerator, and it is taking heat energy from a low temperature region, which is nothing but ice at water at 0 degree Celsius, or you can write it as at a temperature of 273 Kelvin, which is nothing but the low temperature region. So let's say it is taking Q1 amount of heat energy from here and we are doing a work that is equal to W on the engine, and it is applying some amount of heat energy to the surrounding, to a high temperature region. So engine driven by a 200 watt electric motor. That means this work done will be equal to 200 joules per second. Find the amount of water frozen per minute. Outside temperature is given as 20 degrees Celsius, or you can take it as temperature as 293 Kelvin. Specific latent heat of fusion of ice is also given 80 calorie per gram, and the conversion factor is given that 1 joule is equal to 1 calorie is equal to 4.2 joules. So here you can write, if it is removing an amount of energy Q2 to the surrounding, then we know the equation for its efficiency, or if you are writing the equation for coefficient of performance of this refrigerator, that will be equal to Q1 divided by W. Now according to conservation of energy, we can write this Q1 plus W is equal to nothing but Q2. So instead of W we can write it is Q2 minus Q1. So if you are putting this value on this equation, so you can write this is Q1 divided by W can be written as nothing but Q2 minus Q1. Now we know that for a Carnot engine, the value of Q1 divided by Q2 is equal to nothing but is directly proportional to, or is equal to TL divided by TH. So you can write the equation for this COP in terms of temperature, that is TL divided by TH minus TL. So if you are substituting this value like 273 divided by 293 minus 273, there is 273 divided by 20. So we can find out what about the value of its COP, coefficient of performance. It is 273 divided by 20, it will be around 13.65. Now by using this we can find out what about the value of Q1. So the value of Q1 will be equal to COP into W. So COP is 13.65 and work done is 200 joules per second. So the amount of heat energy removed per second will be equal to 13.65 into 200. That will be around 2730 joules. So you can find out how much amount of this ice formed per minute. So in a time of 1 second, this much amount of heat energy. So in 1 minute, we can write this is equal to 2730 into 60 joules. And that is used for converting, let's say, m kilogram of water into ice. So m into its latent heat of fusion. So we can take it as it is 2730 into 60 is equal to m into latent density calorie, that we can convert into 4.2 joules. So you can find out the value of its mass m, that will be equal to nothing but 2730 into 60 divided by 80 into 4.2. So you'll get the answer as around 487.5.